Hello everyone, I hope that you can hear me. Welcome to my presentation called The Curious Case of Copy and Paste, where I will talk about my findings from last year about bugs in browsers and WYSIWYG editors in the copying and pasting, so in the clipboard in general. Okay, so without further ado, let's get the party started. So, the curious case of copy and paste. My name is Michał Bentkowski. I work as a security tester in the Polish company called Securitum. I'm also a training instructor, and in my free time, if I have time, I also like to research browser security. For a few years, I was in the Google Bug Bounty Hall of Fame. Unfortunately, this stopped being the true in 2020. As I already said, I love browser security, and you may know me from Twitter as SecurityMB. And I work for the company SecurityMPL, where we are focused on penetration testing, mainly web applications or mobile application or network infrastructure or anything that can be tested. We also conduct some trainings, also trainings in English. So if you like this presentation, then you can contact us and we may arrange some training. And we also have a very popular Polish website about security in general that is called Sekurak. Okay, but moving on, in this presentation, I'm going to focus on one attack scenario. And the attack scenario is that we assume that we copy something from one page in the browser, and then we paste it in another page or in another application whatsoever. And the question is, could anything go wrong? So let's see that. The first demonstration, oops, I need to prepare it. Okay, it should be prepared right now. Okay, so the first demonstration is that we want to find out what is the kernel version of our operating system. And we may want to Google the information and end up on a page similar to the overflow of the stack. And here we have a very simple instruction that in order to find out what your kernel version is, issue the following command. So I am kind of lazy, so I just select the uname -a, then I copy it, then I go to the terminal, and well, I'm pasting this. And everything looks good. The uname -a was actually executed, and I know what is the kernel version of my operating system. But the problem is that right before uname -a, there was also the rm-f wildcard being executed, which means that the very important file, which was present in this directory before, is no longer here. So, well, this is interesting attack, but it is not new. It pops up in the internet from time to time, and it is very simple. The whole attack is in this snippet. So I am basically assigning my own JavaScript code to the copy event, and I am starting with event prevent default, which means that the default behavior of the browser on copying is stopped. And then I am setting my own data in the clipboard. So I want to set my own plain text, that is rm-f wildcard, then a new line, and uname -a, and another new line. So in fact, it doesn't really matter what I select on this page. Whatever I copy, then always this harmful code is going to be copied to the clipboard. So this attack is more about social engineering, but this is a nice reminder that when we copy something from the clipboard and we want to paste it in the terminal, then we should ensure that this code is safe and that we understand what the code is doing. So I would suggest to first paste it in the editor, like in the Notepad or Vim, make sure that we understand what's going on, and then copy it again and then paste it in the terminal. And that should be fine. Okay, so that was the first demonstration, but from now on we are going to talk about rich editors, or in other words, the WYSIWYG editors. That is, what you see is what you get. So here is another demonstration. So I have an instance of Jira right here, and in Jira we have a rich editor when we add a comment, for instance. So this is a rich editor because I can format the text in here. For instance, I can add that the text is bold or underline or italic, etc. And now let's assume that we want to cooperate with some super secure company, and we need to know what their software stack is. So we just go to their web page, and here we have the software stack, and we just copy the software stack to the clipboard. And then we are going to paste it in the Jira. However, I'm going to split the screen first. So, the idea is that whatever we see in the terminal is what the attacker can see, while the browser is controlled by the victim. So all the victim does is just paste some data from the clipboard. And as we can see, immediately after pasting, some information from the Jira, that is the names of the tickets, were leaked to the server of the attacker. So something magical happened in Jira that made the tickets leak. So what exactly is going on in here, I'm going to describe it in detail in further parts of this presentation, but in short, actually after pasting, a cross-site scripting attack was performed in here, and this is why these tickets were leaked. Okay, so this is the first and second demonstration. So as you can see, when you copy something from one page and paste it in another, well then it can be dangerous. So let's talk about the WYSIWYG editors a little bit more. So let me go back to the Jira, to this WYSIWYG editor. And when I input some formatted text in here, so for instance, this is a formatted text with the word formatted being bold. And when I copy this snippet and then I paste it, well, then the formatting is preserved. This means that the clipboard doesn't contain a plain text, but it somehow keeps the information what is the formatting of the text. We can assume that because we are in the world of browsers, then the snippet is actually stored as HTML. So let's see that. It can be confirmed quite easily. So I'm going to create a simple code in JSBean. And in this case, I am going to add my own handler to the onPaste event, starting with prevent default again. And then I am going to alert the clipboard data, and I am just going to get the HTML from the clipboard. Okay, and then when I press Command V, we can see the HTML from the clipboard. So it is possible on a JavaScript level to get the HTML from the clipboard. Okay, what is also interesting is that we can set arbitrary HTML in the clipboard. So if I change on paste to on copy, then I can use the event clipboard data set data. And now I can say that I want the HTML in the clipboard to be set to, for instance, this is my own HTML. Okay, and now when I select the text on the right and then I copy it and go back to the Jira and paste it, then you can see that I could set in JavaScript the text that is going to be copied to the clipboard. Okay, so the kind of natural idea in here is that if we are able to set arbitrary HTML in the clipboard, then what is going to happen if we try to input some cross-site scripting payload, like image source on error equal to alert1. Okay, so let's check it. I'm going to copy the text again, go back to Jira, and then paste it. And well, no alert was shown, but the image is here. And if we have a look at the DOM tree, well, then we can see that the image is actually here. However, the onError attribute must have been stripped. Okay, and this happens because browsers attempt to sanitize the pasted content. So they ensure that the HTML that is going to be inserted into the DOM tree is free from script elements, the onError attributes, and other similar attributes. But, well, sanitizers are just a piece of software, so they can contain bugs. And the truth is that I found at least one bug in clipboard sanitizers of all major browsers. That means that I found at least one bug in Chromium, in Firefox, in Safari, and in Edge. Now let's start with a bug in Chromium. This bug is already public, so you can just go to the URL. I am going to also paste it in the YouTube chat. And this was a really interesting bug that exploited two behaviors that I noticed. And first behavior is elements merging on pasting. I'm going to show it in a while. And then some shenanigans of foreign content. To make it easy for myself to test for copy and paste bugs, I created a very simple page that is called Copy and Paste Playground. And the basic premise is that I can input some HTML on the left. So for instance, here's an HTML. And we can see the DOM tree of the HTML that I inputted. And then when I press copy as HTML, then this HTML is copied to the clipboard. And when I paste it on the right, I can also see the DOM tree of this rich editor. So I can compare easily the HTML that was originally copied to the HTML that was pasted. We can see that in this case, the DOM trees are exactly the same. However, when I try to copy some cross-site scripting payload, like image with onError attribute, then the onError attribute is being stripped. There's a question in the chat that is this Windows only bug? And the answer is no. All bugs I'm showing are irrelevant of the operating system. So they are more bugs in browsers, not bugs in the operating system itself. Okay, so as we can see, the onError attribute is being stripped from this HTML snippet. Okay, I'm going to share this URL. And moving on, I noticed something peculiar when I was testing copying and pasting in Chromium. That is, let's say that I am going to input some text in here, and then I will add an element who has a style display block and maybe some text inside. Now, when I have some content in the rich editor and I paste the HTML at the very end, then the DOM tree after pasting is exactly the same as the DOM tree that I copied. However, here's the peculiarity. When I put the cursor in the middle of the rich editor, so I am not going to paste at the very end, then the pasted content is different from what I copied. I mean, it is equivalent because the text is exactly the same. Now we have a text and block. However, the span element and the style display block is missing. So it seems that when we are pasting in the middle of the text, then Chromium performs some kind of element merging. So Chromium just wants to ensure that the content is the same, but the DOM tree doesn't have to be exactly the same. But that gave me an idea that if I can make Chromium delete some HTML elements, then it might be useful in attacks because certain elements in HTML can affect parsing in a quite significant way. And of course, right now I'm going to talk about foreign content. Foreign content is one of my favorite parts of the HTML standard because it is extremely useful in finding security bugs in HTML sanitizers and HTML parsers. Basically, to introduce foreign content, we can use one of two tags in HTML, that is math or SVG. And I'm going to move on with math and show you the difference between foreign content and the ordinary HTML. So the difference can be most easily be shown on style element. So when I try to add a child element to style, is this a new element? Then we can see that everything that is inside style is actually treated as text. However, when I add the math element and then style is descendants of the math element, then when I have style in foreign content that is in math, then it is parsed differently, and now style can have child elements, which wasn't true in HTML. And this leads to an idea that, let's say that I have a math element and then a style element and then the anchor element with an attribute, maybe title, and try to put a cross-site scripting payload in here. Okay, so in this case, the on error and the alert one is not going to be executed because the code that kinda looks like an XSS payload is actually within the title attribute, so it is harmless. However, if the math element at the beginning is deleted, then the parsing of the snippet is completely different. I mean, right now the style cannot have any child element, which means that this end tag for style actually closes the style, which means that the image tag is now created in the DOM tree. So it makes quite a big difference whether we are inside or outside the foreign content. So the idea was that if I create a math element, then another element with style display block, and with the trick that I will just show you, then originally this DOM tree is going to be parsed. this HTML snippet is going to be parsed into this DOM tree, which is harmless. But if the math element is deleted at the beginning, well, then this DOM tree is quite a bit different. And well, it worked. This was an idea I had and it actually worked. And here's a video that I sent to Chromium to prove that this actually works. So I am copying some data from my page, and then I have cross-site scripting in Gmail. I also have a cross-site scripting in Wikipedia. And as another example, I have a cross-site scripting in Blogger. And this is actually not a bug in Gmail, in Wikipedia, or in Blogger. This is just a bug in the browser. And well, the bug is also known as universal XSS because of the sanitizer issue. We actually have a cross-site scripting on every single page that has a rich editor. So that was pretty bad. Okay, and there were a few more bugs about copying and pasting in Chromium, but they were quite similar, so I'm not going to talk about them in detail. But you can have a look at a page that is called Chromium disclosed bugs. I hope that it... Okay. This is a page that is a hub of all security issues in Chromium that were made public. Excuse me for a while. Okay, I'm back. Sorry for the break. So here we have a hub of all security bugs that were disclosed by Chromium because they are automatically disclosed 14 weeks after fixing. And you can have a look that if you search for the word paste in this page, then you will find some other bugs about copying and pasting, copy and paste XSS via no script, another universal XSS via copy and paste, and injecting styles via copy and paste. I'm going to talk about it in a while. And this bug I just mentioned, universal XSS via copy and paste. So if you want to have a look at those bugs, then go to Chromium disclosed bugs appspot.com and you can read more about it. The question is, if I tried pasting into LibreOffice, it also supports pasting HTML. I did some basic tests of pasting HTML into other applications, I mean non-browser applications, and there is a potential for bugs, but I didn't really research that. So you can have a closer look at it because I am pretty sure that some bugs are going to pop out. Okay, so I have shown that copying and pasting can lead to cross-site scripting, but now the question is if it is the only risk when we are pasting untrusted content, and the answer is, of course, no. And I also reported a few bugs that weren't about cross-site scripting via copy and paste, but about injecting styles. So it was one bug in Chromium and also two bugs in Firefox and also a bug in Safari. So let's have a look. Let's start with some basic information, that is why injecting styles can lead to some security issues. This is not directly related to copy and paste, but it is important to understand this particular exploit. Okay, so let's assume that we have some kind of input in here, and this input has a cross-site request forgery token, CSRF token, and let's say that its value is some ABCD random. Now, when we add some style sheets, then we can add selectors to say what elements we want to style. So I can say that I only want to style input elements and add the red background, let's say. Okay, and we see that both input elements are now red. I also have selectors that makes it possible to say that certain attribute needs to have some specific value. So for instance, input name must be equal to CSRF token. And now only the first input is in red. And last but not least, I can also select elements not by the whole value of an attribute, but also by part of the value. So for instance, I'm interested in only those input with name CSRF token whose value starts with a letter A, for instance. And the idea, maybe I will comment it out for a while. The idea is that if the first letter of the token is indeed A, then we can make a request to an attacker's server of the attacker. So for instance, attacker server and A. So now the attacker knows that the first letter is A. If the first letter is B, then we make a request with B. If it is C, then we make a request with C, and so on and so forth. Okay, so I am just going to uncomment the style, and as you can see, the browser attempts to make a request to attacker server /A. And now, when the attacker knows that the first character is A, then we can change this CSS and check the second character to find out whether it is AA, AB, and AC, and so on. And now when I uncomment this, and we can see that the requests with the AB letters are issued by the browser, which leaks an information that first two characters from the CSRF token are AB. Okay, so this was the basic idea, and this is how it looked like. So this is a video that I sent to Chromium. The victim needs to go to a page, copy something from that page, and now the victim is going to paste it in Gmail. And as you can see at the bottom, the exfiltrated value is the username of the Google account. Here's a video with the proof of concept that I sent to Firefox, and it is pretty similar. Also, the username of the Google account is being exfiltrated, but in fact, other information can also be exfiltrated. For instance, in case of Gmail, we could exfiltrate the topics, the subjects of the email threads. So this was pretty interesting. Account takeover thanks to copy and paste XSS from the chat. That is a pretty nice finding. So if my research helped in finding that issue, that I'm really glad. So thank you. Okay, so now we know that copy and paste can lead to cross-site scripting. Now we know that copy and paste can lead to data exfiltration via style sheets. And let's assume that I reported all bugs. I mean, that is true, that I reported all bugs that I found to the browsers, and browsers fixed those issues. And are we safe now? Well, the answer is no. Again, because as you already know, in JavaScript, we can get the HTML from the clipboard directly. So if the editor decides to add its own event listener to the paste event, then, well, they can do something really bad, like in this example. So we are getting HTML from the clipboard and then assigning it directly to inner HTML of some div, and this is the obvious cross-site scripting issue. The interesting thing is that practically every single WYSIWYG editor processes pasted data. They usually do it to sanitize content or to make the HTML more consistent. For instance, if we have strong tags or B tags, then certain editors replaces all the strongs with B or the other way around. So basically every single WYSIWYG editor does that. And let's start with the first example, that is TinyMCE. And I am going to show you a few tricks on how specifically I approached finding these bugs in TinyMCE and how I found this bug. Okay, so I'm going back to this Jira because Jira actually makes use of TinyMCE. And the first way to check whether the paste event is processed specially by the application is to go to the Sources tab in Chromium and add a breakpoint. Oh, sorry, this is Event Listener breakpoints. Add a breakpoint on paste event and then just paste something. So maybe I will copy it and paste. And if that breakpoint is hit, then we know that this application processes the paste event somehow specially. But in many cases, it is not easy to go from this place where this breakpoint is being hit to the exact place where the potential cross-site scripting issue may occur. This is because many JavaScript frameworks have some kind of event dispatchers, and it is quite difficult to find the specific piece of JavaScript code that can lead to cross-site scripting. So here we can approach the problem from two sides, because as you all probably know, we have concept of sources and sinks. So we can have a look at the sources of copy and paste potential XSS and sinks of the potential XSS via copy and paste. Let's start with the sources. What can be the source of copy and paste XSS? So maybe I'm going back. Maybe I will go back to the JS bin. Okay, maybe I will just change the code again. So the source for copy and paste XSS can be this pattern. So if the application calls getData on the clipboard data object, then this can be a source for copy and paste XSS. So now I'm going to share a really neat trick that I believe is not widely known, how we can debug that in the DevTools of Chromium. So I am going to add a debugger keyword in here to make sure that code is going to be stopped at this point. Okay, now I have it. And let's have a look at this if clipboard data object. And we can see that this class name of this object is data transfer. And in fact, there is an object that is called data transfer. Now, in Chromium, we have a very neat function in the DevTools that is called debug. And the function debug just accepts a pointer to a function, and it will automatically sets a breakpoint whenever this function is being called. So the idea is that I can take the prototype of data transfer, and now I have the getData function, and I can debug this function. And now when I try to paste something, oh, it doesn't work. Okay, maybe I will try to change it a little. Let me try it again. Oh, maybe I did it in the wrong frame, but I'm going to do this again. So I'm going to debug data transfer prototype get data. Okay, and oh, it doesn't work. What's going on? It should, maybe I try to do an input in here. Something is wrong, but I hope that we will find this issue soon. Okay, well, this is the charm of live demonstrations, that they sometimes don't work the way we want them to work. Okay, I'm going to use undebug. So this is data transfer, prototype get data. This exists. This is fine. Maybe I will make sure that the onPaste event is being called, but it is. So this is fine. And once again, I should probably do it in null.jsbin.com. So debug data transfer prototype get data. Okay. And it doesn't work. This is interesting. Okay, maybe I will have another look in here. Maybe it is not data transfer, but I guess it is data transfer. So f clipboard data constructor. Yes, this is data transfer. So this is fine. Okay, I am going to spend on it like a minute, and if it doesn't work, I will just move on. But I would like to know why it doesn't work. I tested it immediately before this presentation and it worked, so it should work. Okay, once again, debug data transfer. Prototype get data. Maybe I will close the tab, open it again. This sometimes helps. Okay, so here we have the frame, debug data transfer prototype get data, and it doesn't work. Okay, I will try to do something else that I also tested and it also worked. Maybe I will try to do clipboard event prototype prevent default and try on this. Oh, and it works. Okay. So yeah, now this is a proof that this trick actually works, so I can add a breakpoint on the prevent default with this trick. So clipboard event.prototype.prevent default, and that breakpoint was hit. So this is good. The question is why it doesn't work on clipboard data get data. This is data transfer. Okay, so okay, I can undebug this. Maybe I will just try it in Jira because I tested it in Jira and it worked. So let's have a look in here. the debug data transfer prototype get data. I'm going to copy something and paste, and it doesn't work. Wow, this is this is surprising because it did work. I have no idea what's going on. Okay, so maybe I will try to go back to it in a while. So the idea was that I can have a look at source, so I can look at the exact place where the editor is getting the data from the clipboard, but we can also have a look at sinks. And that is a pretty useful event listener breakpoint in Chromium. That is, we have a category parse and set inner HTML in here. But the problem is that the inner HTML is being set basically all the time in the WYSIWYG editors. So here's another trick that we can use, is that I am going to add an event listener on paste. Then I'm going to paste something. And when I'm in the paste breakpoint, I'm going to delete the paste breakpoint and add the set inner HTML. Then the next breakpoint I'm going to hit is going to be the setting inner HTML that was caused by the paste event. That is the idea. And here's a place where the HTML from the clipboard is assigned to inner HTML of certain element. So this is the place I'm going to focus from now on. Okay, anyway, I need to do one more thing. I'm going to delete this breakpoint. Okay. And I'm going to add to clipboard a cross-site scripting payload. Okay, and then I do the same trick again. So breakpoint on paste, and then a breakpoint on set inner HTML. And then we can see that when some value is being assigned to inner HTML, then this HTML is already sanitized. So my goal right now is to identify the exact place in the call stack when the HTML is sanitized. So let's have a look. Maybe I will make it wider. Here we have a setHTML function, and we can see that its argument was already the sanitized HTML. So let's go up. This is also a sanitized HTML. So let's go up again. Okay, here we cannot see the HTML. Okay, maybe try to go up once more. Maybe I will just have another look in here. Okay, this is already sanitized. This is also already sanitized. Okay, but here we can see that this HTML is not sanitized. So this is exactly the HTML that I copied to clipboard. So what we know right now is that this function is being called with unsanitized HTML, but inside this function, the HTML is already sanitized. So this means that the sanitization must happen in here, somewhere in here. We don't know exactly where, but it must happen in here. So I am going to set a few breakpoints, maybe in the beginning right now, and then we will just find the exact place where the sanitization is happening. So I need to delete the set inner HTML breakpoint, and then I am going to paste something again. Okay, so we can see that the A variable is the unsanitized HTML, and we must find the exact place where the unsanitized HTML is turned into the sanitized HTML. Okay, so I'm going to add a breakpoint maybe after this. And we can see that this is still unsanitized HTML. Okay, so maybe here. And well, we maybe have a look at the C, and we can see that C content is still unsanitized HTML. So maybe add a breakpoint here. And now the HTML is sanitized, which means that the sanitization must have happened in this line. Okay, so let's do it again. And then I am going to step into this function call to just find out what exactly is going on in here. Okay, and here is some event dispatcher, and well, I just need to keep going until I see something interesting, until I go out of this event dispatcher. So, so let's have a look. It shouldn't take that long. Okay, here we can see something interesting. So we have a paste preprocess call. And when we go inside this function, we can see that here's a function that is called sanitizehtml. I know I could have just used the search function and look for sanitizehtml or the sanitize name, but this is basically the general idea, the general approach that we can use to identify a place in the JavaScript that performs the sanitization. And what I also like to do is that if I have the sanitizehtml function in here, then I want to create my own function to sanitizehtml. So I'm going to create a function that is going to be called sanitize. And this function is going to do exactly the same what the original sanitizehtml function is doing. And now, okay, I believe that I need to go out of this debugger. Oops, something is wrong, so maybe I will go here again. Probably I defined the function too early. Okay, this can be deleted. And maybe I will try to do it again. So defined my own sanitize function. And this is not what I expected. Okay, because I didn't use the input value anywhere. So the input is actually the first parameter. Okay. Okay, so what I did right now is that I extracted a function in the source code of this editor that performs the sanitization. The upside is that I can easily test the sanitizer right now without the need to copy something from the clipboard and pasting, because I defined my own function that just performs the sanitization, so I can easily check what exactly is going on in the sanitizer. This is a pretty neat trick, and you can almost always use it whenever you see that a page performs some kind of sanitization. So you just try to extract the exact place where the sanitization is happening and define your own global function that performs the sanitization, and then do all the testing on that global function. It just makes everything much, much faster. Okay, so right now I'm going to have a look at this sanitizehtml function to see what exactly is going on inside. Okay. And This function is pretty huge. I mean, what is happening inside is pretty huge, but we can see that here we have some kind of DOM parser, and we see that we have some kind of serializer. So the editor doesn't use the built-in JavaScript DOM parser, but it has its own DOM parser and its own serializer. Here we can see that we have a parse function being called, so this can be pretty interesting. So let's have a look at this function. Okay, and it is pretty big, but if we have a close look, then we will find it wasn't that easy the first time, but it can be done. Let me have a look. Okay, I need to just step a little. And that was a function, another function that was called parse, as far as I remember. Maybe I will just, oh, it is here. So here's another function that is called parse. So, I mean, when I did it the first time manually, then I did it step by step, but right now I just want to make things a little bit faster. So now I have the parse function. And when I go inside, I can see some interesting regular expression in here. I mean, here's some C data, doc type. This looks pretty nice. So this regular expression is in a variable that is called j. So let's have a look. Okay, it is pretty huge and regular expressions are not easy to read, but I am going to use a page that is called regexpr. I can just paste a regular expression in here and have a diagram of this regular expression. And in this diagram, it is pretty clear that this regular expression is used to parse HTML. I mean, we have the less than character, and then HTML comment, CData, doc type, the question mark, the end tag, and the start tag for HTML elements. And when I had a look at this regular expression, there was one thing that immediately caught my attention, and it is this part. This part with HTML comments. Because there is an interesting quirk in how HTML comments are parsed. Let's have a look. Basically, when we open an HTML comment, then the well-known way to close a comment is to use the ---- greater than character. And now the letter A are outside the comment. But there is also another way to close a comment, that is ---- and greater than character. But if we have a look at this regular expression, we can see that it is assumed that the comment must be closed with ---- greater than. So this gave me an idea that maybe I can open a comment, close it in the alternative way, then add XSS payload and close it in the normal way. Now, the editor will think that everything that is currently selected is inside the comment, while when the browser parses exactly the same HTML, well, then the comment is closed in here and the image is created in the DOM tree. So let's have a look. So I will use the sanitize function and see what happens to the comments. And maybe I will just deactivate breakpoints. And as we can see, the comments are left as is. So the idea should work. So I try to add the cross-site scripting payload after the alternative closing of HTML comment, and then close it the normal way. And as we can see, nothing is being sanitized in this snippet. So now, after all this, the idea is that when I copy this snippet to the clipboard, and then I paste it in the rich editor, then I have a cross-site scripting on copying and pasting. So this was one of a few bugs that I found in the TinyMCE. They are all fixed right now, but well, it was a pretty interesting journey to find those issues, and maybe after watching this video you will be able to find issues in another editors of another WYSIWYG editors. Okay, so going back to the presentation, so TinyMCE employed its own HTML parser, and the parser didn't take it into account that the HTML comments can be ended in two ways. So this payload actually made it possible to make an XSS, because according to TinyMCE, everything is a comment, so this markup is safe, but the browser parses it differently, and that led to script execution. So if you're a developer, then make sure to update TinyMCE to the newest version so that you are not vulnerable to this type of bug. Another popular editor is CK editor, and it had a really similar issue, and the payload was like this. The only difference is that there needed to be a special tag CKE protected in the comment, but I also used that idea of alternative HTML comment ending and used the cross-site scripting in here. So you might have a look at the old version of CK editor to find out what exactly happened, but I'm just going to show a demonstration that it worked. So I'm going to add the tag CKE protected in here, copy as HTML, then paste it into the old version of CK editor, and as you can see, I have a cross-site scripting. Okay, and the last example was Froala. I don't know how to pronounce it, sorry. Froala. So Froala processed HTML as string, and it is almost always a bad idea, and it was also a bad idea in this case. So here's the payload. So I have some element with a no script inside. Here's the cross-site scripting payload, but well, it is inside the title attribute, so it should be safe. However, Froala in the first step decided that all no script should be substituted with this tag. Then the HTML was parsed somehow, which meant that the single quote was substituted with double quote. And then the original content of the no script was substituted back, which meant that the double quote that was inside in here that was harmless now is harmful, because the single quote was changed to the double quote, and now it closes the title attribute and the image is created in the DOM tree. Okay, so that's all I wanted to say today. And so what exactly happened in that Jira payload? So let's have a look. So there was actually a trick that this payload took HTML of current selection and appended to the current selection, the XSS payload. So opening of an HTML comment, then closing of HTML comment. And here's the payload. And the payload was just getting the list of latest issues in Jira and what is the key of this issue and what is the summary of this issue. And all of this was exfiltrated to the server of the attacker. So that was the whole idea. This is a real-world example of how cross-site scripting can be exploited. Okay. So thank you very much for your attention. Let me know if you like that presentation. If you want to have a security audit or penetration test or a training about security, how to test for security issues, or how to write software so that it doesn't have security issues, then please contact us at SecurityMPL. You can also have a look at my training called XSS Academy, when I'm showing some advanced tricks on how you can look for XSS issues in modern web applications. Okay, so please also subscribe my Twitter account. If you have any questions about this topic that I just covered, then you can ask me on Twitter, and this is the easiest way to contact me. Okay, so thank you very much for your attention. I hope that you enjoyed that presentation. So have a good afternoon and happy hacking. Thank you.